So today we are going to start with what? Kinetic theory of gases. Do you know anything about kinetic theory of gases? Anyone? Can you hear me?
Yes, sir.
Do you have any idea about kinetic theory of gases?
No, sir.
Okay. What does kinetic means? You have potential energy and kinetic energy. How are these two different? Kinetic energy is the energy when you are in motion.
Stable position.
No,
Okay.
when you are in
Oh,
Motion.
motion,
potential energy, sir.
Motion.
potential energy is only depends on what? Your position. And your kinetic energy
Motion.
is related with the motion. So actually, what does this kinetic theory of gas basically deals with? With molecules of gases in motion. Clear?
Yes,
That's the
sir.
whole idea. You all know heat is a form of what? Energy. Form of energy, as you all know. And in kinetic theory of gases, what do we usually do is we look at a microscopic level. Clear? Microscopic level, and you see the motion and you study the motion of what? Each and every particle or molecule, and how does they generate heat or energy. Okay, those are the things which you will study in kinetic theory of gases. Clear? Is it clear? So what are the different states of matter? Do you know? States of matter.
Yes,
What are
sir.
they?
Solid, liquid,
Okay,
gas.
solid, liquid, and gas.
Yes.
Apart from there is one more that is called what? Plasma, but for a time being, this three will do. So what is the basic difference between these three?
In solids, molecules are tightly bounded,
Okay,
binded. Then in
liquid,
liquid, it
yeah,
is
slightly far
much
away from each
lesser than solid. Then in gas, the molecules are freely moving.
other. Okay, so the whole idea is the molecules are
Molecules.
freely moving. They have very weak interaction between each other. That is the whole point. Clear?
Yes, sir.
From that one gets what? Ideal gas equation. At extremely low pressure, what do you get? At low pressure, what will happen? Your real gas will behave like what? Your ideal or perfect gas. So what does this mean? The interaction when the pressure is extremely low, the interaction between each and every molecules are what? Extremely weak. Clear? So what we can think is, we can think them of moving independently of each other. So in that respect, they will follow this relation, PV is equals to RT. Do you know this relation? Ideal gas equation. And this equation is called what here? Ideal gas equation. Clear? A product of pressure and volume is proportional to only temperature. Is it clear or not? Have you all studied about this ideal gas equation?
Yes, sir. कहाँ पढ़ को थे?
Okay, then it's fine. So this is your equation which governs your ideal gas. So Okay. Now in kinetic theory of gases or in kinetic model, there are few of the assumptions. Yeah. Now I'll tell you what are the assumptions. Kinetic model, there are few assumptions. One is gas is made out of what? Gas is made out of what? Small molecules. Clear? They are made out of what? Small molecules. And these molecules are of what? For a given gas, for a given gas, all of these molecules are same. Clear? From the kinetic model, what each and every gases are basically made out of what? Small molecules, which are identical for a given gas. For different gas, it may vary, it may be different. Clear? That is your first assumption. And second assumption is what? The distance between the molecules is large as compared to that of a solid or liquid. So basically, the force between the two molecules are negligible. Second assumption is, and the third is, the molecules are continuously moving. The molecules are always in motion. Now, for this, your size of a molecule is infinitesimally small compared to what? Your size of a container, where a gas has been confined. If you have a container full of gas, then the size of each molecule can be ignored compared to this size of the container. And also, these molecules are what? They are like a very hard sphere. Clear? Hard sphere which goes under what? Elastic collision. Because the molecule also collide with each other, and what they will do is they will go under what? Your elastic collision. So what will happen during your elastic collision? In your elastic collision, what will happen? In elastic collision,
Energy is conserved.
Okay, energy is conserved over from there. Abib, what you are telling?
So दुईटा मास भएको अब्जेक्ट हुन्छ कोलाइड हुन्छ र उनीहरू फेरि आफ्नो आफ्नो डाइरेक्सनमा जान्छ सर
Basically, the momentum is conserved. Clear?
Momentum.
Linear momentum is conserved. That is very important.
Yes, sir.
In elastic collision. So that's why they are always in motion. Clear? Due to elastic collision. Because once it is set into, and also the collision with the walls, it collides with the wall as well. So the collision with the walls are also what? Yeah, elastic. Clear?
Yes,
Basically,
sir.
the molecules are what? Perfectly elastic. That is the whole idea. Now, the last one is the time of impact. What is the time of impact? The time of impact means whenever they collide, the time taken during the collision. Clear? That is what? Instantaneous, or what? That can be neglected as compared to the time taken for a molecule to travel between two collision. Yeah. So
Yes, sir.
you all know about the mean free path, no? Mean free path, you all know. The time, the distance traveled between two successive collision. Do you all remember? We have done in this in electricity.
Yes, sir.
So the time between taken,
Between two successive.
the distance traveled between two different successive collision, or the time taken for during this two successive collision is much greater as compared to your time of impact. Yeah, it's very small.
Yes, sir.
Because the two molecules, what will happen is the two molecules, they will come. And what? They will collide with each other. And they will again move away. Now the time of this contact or time of this impact is extremely less as compared to whatever the time it takes before the collision. Clear? Now in the kinetic theory, what we are only dealing with what? This microscopic object, which is called your what? Molecule. Now how do we describe pressure with the help of this molecules? Now what we'll find? Expression of the pressure exerted by a gas. One more thing, do you know which unit we are in? Do you all know?
3.
Good. So expression for the pressure exerted by the gas. Let's first just consider this two-dimensional body. Actually, I intended to make this a square, but leave it. Nevertheless, okay. Let's say your molecule is moving in this direction. Clear? Now this is confined between these two walls. Clear? Now after certain time, what this molecule is randomly, according to your kinetic theory, what this molecule is continuously in motion. Clear? Then what will happen is this will come and heat over here. It will hit the wall. Yes or no?
Yes, sir.
But what? It's an elastic collision. Then what will happen? It will give some momentum to the wall and move with this equal same momentum on the opposite side, because the momentum must be conserved. So due to due to continuous bombardment of these molecules on the wall will give you what? Pressure. Clear? Is it clear or not? Because it is continuously trying to push this.
Yes, sir.
So that's why what? It will create some kind of pressure. Is it clear or not? That is, for a given temperature, it will have what? It will produce certain temperature. It will give you certain pressure. So now if you check this, the molecules are continuously hitting the wall. So the pressure will keep on rising. Yes or no? Will the pressure
Yes.
keep on rising? The answer is no. After a certain time, what? The pressure will be constant. Clear? At that
Yes,
time,
sir.
the span of that time is very small actually. As if it seems like the pressure has already adjusted. Why? Because for a given temperature, the molecule will move at a certain velocity, because it will only have a certain kind of kinetic energy. Clear? Now, as you keep on increasing the temperature, what will happen? This molecule will start moving faster because they will get excited due to heat. Clear? So they will carry larger momentum. So they will hit the wall harder. So that's why the pressure will increase with respect to temperature. Is it clear? So for a given temperature, it will be fixed. because they will always, for constant temperature, they will always move at a what? Constant velocity or constant speed, sorry, at a constant speed. Clear? Now,
Yes, sir.
if you increase the temperature, what? The pressure will increase. So let's try to get an expression for that one. Now what do you have? You have a three-dimensional box. This is very badly made box, but still it's fine. Deepika? So let's say this is your box. Clear? And the side of the box are what? A, B, C, D, E, F, G, and H. Now your molecule is moving over here. Do you know about degrees of freedom?
Yes, sir.
So if a molecule is placed over here, how many degrees of freedom will it have?
In the space.
A single molecule sitting over there, how many degrees of freedom will it have? In how many different way this molecule can move?
3.
Yeah,
Yeah.
three. Because it depends on your dimension. It can either move in X, Y, or Z
X,
direction.
Y, or Z.
So how many velocity components will be there?
3.
And what are those?
I, J, K.
Vx, Vy, Vz, no?
Yes,
Velocity.
sir. Well, other.
Now, can I write the magnitude of velocity like this? The particle is move out the molecule or particle is moving with velocity v. Clear? Now this velocity can be write as this one v square as vx square plus vy square plus vz square. Is it clear or
Yes,
not?
sir. Yes, sir.
Who didn't understand? I'll just give you an analogy with respect to two dimension. Clear? So it will be easier for you to understand. Let's say this is your x component of velocity, this is your y component of velocity, and a particle is sitting over here and moving over in this direction. So if this is v, then what will be its magnitude? Using Pythagoras, it will be vx square plus vy square. Clear? So same thing for your three dimension. It's have vx, vy, and vz. So that is your magnitude of your velocity. Now let's consider that each side of is of length what? Length, breadth, and height is of L. Clear? And this container contains what? A perfect gas. Now what will happen? This perfect gas will, actually there will be n number of such molecules which will be randomly moving inside this box. Yes or no? Yes or no?
Yes, sir.
Let M be what? Mass of a molecule. Mass of a single or mass of each molecule. And N be number of molecules. Can we take the mass of all the molecules M each? M, or will there be difference in their mass? Or should we write M1, M2, M3? Any thoughts? What should we write? Should we write M or M1, M2, M3?
Mass the same हुन्छ हैन sir?
Yeah, because what we have assumed that this, for a given gas, the molecules are identical.
Yes sir.
So that's why their masses also will be what? Same. Yeah. Is it clear? Now the molecule
Yes,
is
sir.
moving randomly. Apart from that, the total velocity is given by what? Should we write V or C? Let's write V1 square. For a single molecule is given by U1 square. UVW. Let's use C. C1 square is equals to U1 V1 square plus W1 square. This is Vx, Vy, Vz. Okay, should I use Vx, Vy or U1, U2, U3? Let's use U1. Clear?
Yes sir.
Now, the component of a velocity with which the molecule P will strike this molecule will strike this wall. So what will be the momentum of that molecule when it strikes this wall? How much will be the velocity? A will be the momentum when this particle hits this wall. It will be basically what? From the x component, it will be what? Mass into velocity.
Velocity.
Yeah. Is it clear?
Yes sir.
Why I'm using only U? Can you see? Because first we are only considering the x component. Clear? This is the
Yes, sir.
amount of, because these are three independent. Whatever it hits on the wall, that is given by a x component. Is it clear? Because x component will be hitting it in this manner. Clear? Now
Yes sir.
now the change in momentum is what? Momentum on here BCFG is what? By which it will hit the wall is M into U1. So the change in momentum is what? Because momentum will be how much? Because this molecule will come and hit the wall over here. As soon as it will hit the wall, what will happen? It will bounce back. Clear? So now there is a change in momentum. Is this point clear or not? So the change in momentum
Yes,
will
sir.
be how much? M into U1
M
minus,
U1 minus M.
because it is moving in opposite direction, the momentum. So that's why if we want to find the change in momentum, the change in momentum is how much? Is this clear?
Yes sir.
Because first initially it was moving towards the right, now it's moving towards the left. Now you are taking the difference and you are getting what? 2m u1. Clear?
Yes sir.
Now, as the velocity of the molecule is what is the velocity of the molecule? Is u1. Velocity of the molecule is how much? u1. The time interval between two successive impact on the wall BCFG is how much? On your right wall. Clear? The time interval between two successive impact or collision or impact is given by what? So what is time? Velocity is equals to distance by time. So what is your total distance traveled between two successive impact? This was your wall. This only consider this. It was moving with velocity of what? U1. Between two successive impact is, first we'll start from here and it will go over here and it will come over here. That will give you what? Two successive collision. Is this point clear? Is this point clear?
Yes, sir.
So the total distance traveled will be what? L on your left side and L on your right side. So the total distance traveled will be 2L. Is this point clear? Between two successive collision.
Yes, sir.
So their total distance traveled is what? Or what you can write is P is equals to distance traveled by U1. But distance travel is what? Your 2L. And this is your U1. Is it clear?
Yes, sir.
Okay. Now this is for a let's say this we give in second. Clear? So the number of impact per second will be how much? Impact per second will be how much? For t time it was, we don't know this number of collision. Now for n, so the number of impact per second will be how? Basically this is what your frequency, 1 divided by t. Is this point clear? Number of impact per second. So for one impact, for one successive impact, it was what? 2L. So number of impact per second will be 1 by second, or basically this is what your frequency. Frequency of impact. Clear? Is it clear or
Yes,
not?
sir.
So your change in momentum produced in 1 second due to impact of the molecule is what? Change in momentum produced in 1 second. In 1 second due to impact of the molecule will be how much? Whatever momentum we had, we have to multiply with what? Here per second, which is U1 by 2L. U1 square divided by 2L. Clear? Is it clear?
Yes,
So this
sir.
is the momentum in 1 second. We basically multiplied by what? Your frequency. So now if you check this, do you see something? mv square, have you seen somewhere? Half mv square. If I slightly write this in this form, if I take this out, mu1 square into 1 by L, what does this look like? Because your change in momentum is, rate of change of momentum is what? Rate of change of momentum is what? What is rate of change of momentum?
Half mv squared is kinetic energy.
Good. For a time being, what? This is here basically. Now change in momentum is what? Change in momentum is force. Do you remember?
Force.
Now what will happen if you divide kinetic energy with distance? It will give you force, no? So this will be your force. This is your force. Because change in momentum is force. If you, this is what? Your kinetic energy, which is your joules, which is force into displacement, And again, it's divided by displacement. So it will be what? Force. Is this point clear? Over here. So we'll proceed now. I think it's clear.
Yeah. Yes, sir.
So the force on or the x component, basically we are what we are finding. We were only finding the x component of force. Now the force produced due to how many molecules did we had? N number of molecules. Now the force on your right side of the wall due to n number of molecules is how much? Basically this much. M by
Sir.
this two should cancel, no?
Sir.
Is it clear now?
Yes. Yes, sir.
No, I think it's fine. M by L U1 square plus U2 square plus U3 square plus so on till UN square. So this will be the total force due to n number of molecules. Is it clear? This is only the x component, but is this point clear or not? Clear?
No, sir.
Okay. For a single, you are able to follow for a single molecule. Till here, is it fine?
Yes, sir.
Okay. Till here, it's fine. Now this is only for what? For a single molecule. For one molecule, what? You had UM U1 square divided by L. This was your force due to single molecule. Clear? Now let's say you have two molecules. Now both are hitting the wall. So your total force will be how much? Let's say it's moving with velocity U1 and this is moving with velocity U2. Then your total force on that wall will be what? Force due to this first molecule, which was what? Divided by L, plus your force due to your second molecules, which was this one. Is it clear?
Yes, sir.
Now, if you continue adding more number of molecules and number of molecules, what you will get? You will have to add everything. Can we take M and L? They are constant. So can we take M and L out? So whatever which is sitting inside is this. Clear? Let's say
Yes,
this
sir.
has U3, U4, so on and so forth. So finally, we will end up with this as we have n number of molecules. Now, do you know what is pressure? Now we are finding what? Pressure. Pressure is what? Force per unit area. Is the pressure force per unit area? Now the pressure produced on your right side of the wall is, what is the expression for pressure?
Force per unit area.
Good. Now this molecules are hitting to what? To your right wall. So the pressure produced due to this n number of molecule is force, as you have already over here. So what is the area? Area of the wall on your right. I was L, this was also L. So area is how much? L into L,
L into L.
L square. L square.
L square.
Basically square it's. So your force on your right side of the wall, or either right or left, or the left also, it will be same. Because these are only a x component of your force. Either way, it will be same. Because similarly, if you consider the left side of the wall, the molecules will be hitting exactly in the same manner. Clear? Is it clear? So your pressure on the
Yes,
x will be given by what? M by L, U1 square plus U2 square plus so on up to UN square divided by what? L square. So your total pressure produced on your either left or right side of the wall is how much? M by L cube. into sum of all the component of your velocity. Clear? Now this is only for the x component. Now if you consider the top and bottom part, clear? And top and
Yes,
bottom
sir.
part was given by, let's say, v. V gave you the velocity over here. Then p of y will be also be exactly same, but this will be v1 square, v2 square plus up to vn square. Is it clear? On top and
Yes. L cube allow, sir. M
L
L
cube.
cube.
Yeah, exactly. Now there's also this side. This and this. Over here is moving with what? W. This is your, sorry, this is your Z component.
Yes, sir.
Either way, but the idea, I think you know what. So PZ will be what? M by L cube, W1 square plus W2 square plus so on and so forth, WN square. Is it clear? Let's choose the coordinate in this manner. This is Y, this is Z, this is X, then it will be okay. Now this is the pressure produced on either side of the wall, either on X direction or the Y, or either on Z direction. So average pressure will be what? So this is the combined pressure due to all a component. So average pressure is what? So average pressure is what? Add up all the pressure divided by total number.
Divided by 3.
3. But you could have asked me one question, but whether this pressure will be more or less, because the molecules are hitting either side of the wall. So shouldn't this be twice? I'm just asking you a question. Because should we not consider because there are 6 sides of the wall. Yeah. As the molecules are heating over here also, maybe it will be heat over on your left side of the wall also. Clear? Simultaneously, it can hit both the walls. So should we add pressure over here and pressure? So the total pressure will be 2px on the x. I'm just asking you the question. Is my point clear?
Yes, sir.
So the pressure will increase. So pressure should be more. Even if you had 2 pressure in this manner, when you take the average, what you will do? Px plus Py plus Pz. Over here, how many walls you have considered? 6 walls. 2 for this, 2 for this, and 2 for this. So that's why it should be divided by 6. So either way, you'll end up with the same expression. Clear? So your total
Yes, sir.
pressure will be what? Px plus Py plus Pz. So what you can take this M3L cube common, and what you have? U1 square plus V1 square plus W1 square plus U2 square plus V2 square plus W2 square plus so on and so on up to square plus Vn square plus Vn square. That's it. So previously what we have seen, this thing will give you what? This thing will give you what? C1. This will give you what? C2 square, sorry. So finally what we can write this as? Pressure Ps M by 3L cube C1 square plus C2 square plus C3 square, so on and so forth up to Cn square, where your C was defined as U square plus V square plus W square. Now, do you know about root mean square velocity?
Yes, sir.
Okay. Let's write all of this sum as what? C. Let what? CB root mean square velocity. Why do we usually take root mean square velocity? I think we have discussed previously also. Why do we consider a root mean square velocity? Do you remember? Because if we just consider a simple average, then what? The total velocity, the average or the mean velocity will be what? 0. Do you remember why? Because of the random motion. Because
Moving
the
in all
particles
directions.
in all the random motion, so the velocity component may cancel out each other. So to give you what? The resultant velocity as what? 0.
0.
Let's see with the root mean square velocity. So what? C square will be how much? C square will be how much? C2 square, C3 square, up to Cn square divided by n number of molecules. Is it clear why? Because when you take the average of velocity, what do? You add up all the velocity and divide it with the number of component or number of molecules in this case. Clear? So how many C's and C1s will we have, or basically how many V's and V1s we will have? It will depend on your number of molecules. So this will give you what? Root mean square velocity. Clear?
Yes, sir.
So finally, what do we end up with? So we end up with what? P is equals to M. P pressure is equals to M divided by 3L cube into C squared
1
but
square.
into N it will be. Is it clear? What? Is this clear? Because we want to find this quantity, this is sitting over here, and we want to substitute over here. We just substituted this over here and we got NC square. So your P will be how much? N into MC square. Can we write this L cube as volume?
Yes, sir.
L cube is equals to volume. So N into M. M is the mass of a single molecule and N is a number of molecules. So if you multiply this to what you'll get? You'll get a total mass. Is it clear?
Yes, sir.
So your P pressure will be given by what? 1/3 of
M C square divided by 3V.
by V. Clear?
Yes, sir.
So mass per unit volume is what? Can we write this as density?
Yes, sir.
Okay. So your pressure can be written as what? 1/3 of rho C square.
Rho C square.
So this is the pressure produced due to a molecule. Clear?
Yes, sir.
Here what we have assumed, I think, and also from here, what can you find? C, root mean square velocity will be how much? 3P by rho square root.
Root over. Yes, sir.
From here you can find over here, but what we have considered, we have considered the particle only have what? The molecule only have a kinetic energy. Clear? So that's why we consider only a velocity component. So that is very important. And also these molecules are moving randomly and they only have the contribution of the energy is only from the kinetic part. So basically that is what we consider in the kinetic theory of gas. particle always in motion. So they do not have any interactive force, so they do not have any potential energy, in short. Is it clear now?
Yes, sir.
So tomorrow we are going to start with what? Some different properties. Like here we have to find your root mean velocity, most probable velocity, and those things we'll do it tomorrow.
Yes, sir.